Hi, in this video we're looking at Skill Builder Plus 8.7, and this is a great question because it's now looking at energy that's emitted or heat that's emitted, but instead of looking at the fuel that's going in, it's looking at, well, it is looking at the fuel that's going in, but instead of calculating how much heat is produced, that's already given, and the question is how much butane do you have to put in the reaction, how much fuel to create that heat. And I can really see connections if you were a real-life engineer and you were looking at to produce how much heat or how much fuel would be needed to produce heat on the space station. If you are looking at maybe a chemical reaction that needs quite a bit of energy, or maybe you're looking at producing heat in a home and you want to know how much fuel is needed to produce that amount of heat for years. So I can see a lot of connections into real life problems that's going to involve knowing how much of the reactant you need to put into the system in order to create the heat needed. Also, we're looking at the gas that's produced. How much carbon dioxide, carbon dioxide is produced when you burn this much butane. And of course, carbon dioxide is a greenhouse gas. So again, lots of connection to real life, world problems, climate change, that kind of thing. So let's take a look at how to solve this problem. So first, I like to write down what I'm given and what I'm trying to find. So I am trying to find the mass of butane. So that's going to be the mass of C4H10. And then what I'm given is 1.5 times 10 to the power of 3 kilojoules of heat or energy, and that's going to be in the negative round because I'm emitting this energy and not absorbing it. So that's why I have to have the negative here. So the conversion factors that I'm looking at are, first of all, that I get 1 mole of CH of my butane, C4H10, excuse me, is equal to this negative 2,658 kilojoules of heat emitted. So for every mole of C4H10, I get this negative 2,658 kilojoules of heat. And then the other one that I know is going to be my molar mass, and I know the molar mass of butane is, when I calculate it, is 58, sorry. I've already calculated this. From the periodic table, 4 carbons plus 10 hydrogens gives me 58.14 grams is my molar mass. So I'm going to use these two conversion factors to help me find how many grams of butane give me this amount. The last thing I'm going to do, I'm just going to bring it down just, oh, maybe not that small. The last thing I'm going to do is do my map. Now, different from the skill builder for 8.7, instead of going from grams to moles to kilojoules, I'm going to go backwards. I'm going to start with my kilojoules. I want to get to grams. I can't do that big leap. I have to go to moles first and then to grams. So that's the map that I'm going to use, my solution map. So I'm going to start with my kilojoules, and that's why the map is so great, because it kind of helps guide me in my solution. So if I want to produce 1.5 times 10 to the power of 3 kilojoules of energy, the first thing I need to do is convert that to moles. So my conversion factor is going to be this, which is 1 mole of butane is equal to negative 2,658 kilojoules of heat produced. And then my kilojoule units are taken out, and then I'm now gone from converting kilojoules to moles. So that's done, and now I have to go to moles to grams, and what I'm going to use for that is my molar mass of butane. So I'm going to put 1 mole on the bottom in order to cancel out, that's the word I was trying to find, C4H10. And then on top, I'll have my grams, which are 58.14 grams of C4H10. My moles cancel out, leaving me with my grams, and that's going to be my answer. So the last part of this is going to be multiplying all my numerators together and then dividing by all of my denominators together. So I'm going to go negative 1.5 times 58.14, and that's going to give me negative 87.21, and then I just tack on the 10 to the 3 when I'm doing multiplication across. And that's going to be over negative 2,658 times 1, so negative 2,658. And then I'm going to divide. Now what I might do first is just put that into a regular number. So I'm going to move my decimal over by 3. So that's going to be 87210. So that becomes 87,210 divided by negative 2,658 grams. And then when I do the division on that, I get 32.81 grams of butane, which is needed to produce 1.5 times 10 to the power of 3 kilojoules of energy. So that's part A of that question. Let's go back and look at part B. Part B, what is the mass of the CO2 produced? Well, first of all, I'm going to need a couple of conversions for that. You can see that we have 4 moles are produced when you put, or when 2,658 kilojoules are emitted. So I'm going to use that. Here is part B. I'm going to use that conversion factor, that 4 moles of CO2 is produced when 2,658 kilojoules of energy are emitted. The other conversion factor I'm going to use is the molar mass of carbon dioxide, which is 44.01 grams per mole of CO2. And then what I need to do is I need to do my solution map again, and it's how much energy or how many grams of CO2 are emitted if 1.5 times 10 to the power of 3 kilojoules are emitted. I'm trying to find the grams of CO2 that are produced. So that means I'm going to go from my kilojoules to find out my grams of CO2, but it means I have to find my moles first. And then I'll get my grams. So that's the steps that I'm going to do first. So my kilojoules is, I am given negative 1.5 times 10 to the power of 3 kilojoules. And I'm going to change that over to moles. So I have 4 moles. So 4 moles of CO2 are produced, or can produce, this negative 2,658 kilojoules. My kilojoules will cancel out. So I've done that one. And now moles to grams of CO2. I'm going to put 1 mole of CO2 at the bottom, and that's going to be this conversion factor here is equal to 44.01 grams of CO2. My moles cancel out, and that's going to give me the grams of CO2 that are produced. So going across the top, I will have negative 1.5 times 4 times 44.01 is equal to 264.06, that's in the negative realm, times 10 to the 3. I always like to kind of leave this off when I'm multiplying across, and then I just tack it on at the end, and that's going to be over negative 2,658 kilojoules. And then what I do is I'm going to change this over into a regular number, so I get, give myself a little bit more room, I get negative 264,060 divided by negative 2,658, and then I'm left with 99.35 grams of CO2 that is produced when 1.5 times 10 to the 3 kilojoules of energy is emitted in the form of heat. So a little bit of a different perspective on the Skill Builder 8.7, but I find that it's really cool that you can look at how much mass, or the amount of a reactant that you need to produce a certain amount of energy, the amount of product that is created in order to make this heat, and vice versa. Really cool. So I'm just going to blow this out a little bit so that you can see the answers all in one. Feel free to press pause on the video if needed. Well, that's it. Skill Builder Plus 8.7. Bye for now.